In this second part of the meeting video, I just want to discuss page 3 of these class meeting notes. And the idea behind this part is just to get students curious about and wondering about what drives the endothermic process. So students seem, again, good with the fundamental graphs that if you have a reaction which starts with high chemical potential energy, that is to say the energy stored in the bonds, and you end up with low chemical potential energy, that means that your reaction vessel, this is just supposed to be a showing as reaction progresses, the chemical potential energy drops. That's the exothermic reaction, that the thermometer stuck in the reaction vessel gets warm. If your hands are touching the container, they feel the warmth. That's an exothermic reaction. And then chemistry has the, quote, uphill reaction as well. And that is where your products have a higher stored chemical potential energy than the reactants had. So as the reaction proceeds, it's sort of an uphill climb, one would say. And one has to wonder, well, what drives that process? Why would a reaction vessel get spontaneously cold? Why would a reaction proceed in a way that gives the products more stored energy than the reactants? And so that is a fascinating part of the topic. And what I'm looking to do here is just give you some sense of it in a related way. So I've indicated, well, in a related way, we can ask ourselves the same thing. And so, not sure if this bothered you at the time, but earlier in the year we were studying heating curves. And that's where we start with a solid, and at 0 degrees we have the solid, this is water, this particular heating curve is for water. The solid melts to become liquid, and then we go through a portion where the liquid warms between 0 and 100. And then once the temperature reaches 100, then we have the vaporization from liquid to gas, and that's pretty much what we experience in the classroom. Theoretically, if we were able to capture that gas, we could then make the gas have a temperature. We could then heat it above 100 Celsius. But we also know that evaporation exists. So if we had a container of water, the top off of it, so there's no lid on this, what we would find over time is that the liquid evaporates. And we have to wonder, well, why would it do that? Because if the liquid is less than 100 Celsius, so if it's 25 Celsius in the classroom, it's supposed to stay liquid. So what would make it go into this higher energy state of being a gas? And so that's the third thing that I'd like to explore. I'm not going to pretend to be able to address it here. I want to have a different set of notes for that maybe have a few different diagrams. But in terms of a class meeting to sort of set the stage for the work that you're going to do, as I fade out of this particular class has 3 components to it. There's one, making sure that students are thinking about what one observes in the classroom to conclude whether a reaction is endothermic or exothermic. There is 2, the idea of limiting reactants, not quite an energy topic, but related to chemical reactions, and that's going to use an online simulation. And the third part is just to give students some sense of wonder around the endothermic process. And I didn't give a full answer, but perhaps I've at least made you say, yeah, why does water evaporate when it's just at room temperature? And so with that, we will end our class meeting. Thank you.